Hi folks, this is Smart Traffic Control Systems by Rahul Kolle and Pavan P. Road traffic is on the rise today and it's worse than ever before, and it's one of the biggest problems and hurdles in India's quest for the developed nation tag. Poor infrastructure facilities are unable to handle the increasing traffic, and this results in generating higher traffic in already crowded areas like metropolitan cities and upcoming urban landscapes. And speaking about the ill effects of traffic is something that is not necessary, as all of us are completely aware of the situation. World population is increasing at the rate of 1.1% annually, and so is the traffic with the population. But the techniques and the approach towards traffic management has remained the same. The new techniques that can be introduced are PLC, SCADA, and image processing. We'll talk about the following in the further slides. One of the first methods that can be employed is inductive loop detection. In this method, there is one or more turns of insulated wire and placed in a shallow cutout in a roadway. A wire runs along the road to the controller, which consists of the circuit and is located in a controller cabinet. When a vehicle passes, it is detected, and hence vehicle is recognized on the lane. This method indicates the density of vehicles, occupancy, and passage of vehicles on the lane. There are drawbacks due to poor performance and also repetitive maintenance, which results in digging of roads and in turn causes traffic accumulation. Infrared sensors. Infrared sensors are used to detect energy emitted by vehicles, road surface, and other objects, and these are captured by receptors. These are, however, affected by fog, rain, and other environmental factors, and requires regular maintenance. Video analysis is probably one of the most high-tech techniques employed today. Uses cameras placed near signals, and cameras contain a processing unit along with a communication unit, and they recognize the vehicles passing through by their registration number or number plates, as we commonly call it. Smart traffic control systems discussed above have been given in the following table. RFID is one of the most employable techniques using existing infrastructure in the nation today. RFID stands for radio frequency identification and consists of a controller and a tag. It's a wireless device which uses radio frequency electromagnetic fields to transfer the data, which is used to track and identify objects. It does have a few drawbacks, however. It's not completely accurate at times. PLCs that have earlier been spoken about are acronyms for Programmable Logic Controller, and in this method the heavy traffic and congestion is reduced by using PLC based diversion system. PLC uses weight sensors to detect how much weight or how much density of vehicles a particular lane is carrying. The two types of PLC controls are congestion control or diversion control. Image processing is, again, as we spoke about, one of the latest and high-tech technologies. Consists of cameras that monitors traffic at regular intervals, does so by capturing videos. There are various phases of image processing that, as you can see below. Divided into 3 phases. The above methods are some of the more advanced methods of controlling traffic. They are better than the conventional ones, as they can operate during heavy rain and are not affected by the environmental factors. They are more reliable and can predict and detect vehicles more efficiently and take lesser time than previous method. It also prevents the scope of human error. There are problems and challenges, however, as every solution does. Most of the smart traffic control systems cannot be used in developing countries as they have lack of infrastructure to implement them. The maintenance of the new systems methods are expensive, and they should be regularly monitored and maintained. Initial cost is also high. There is a lack of professionals who can operate these systems, and a rigid database needs to be maintained. These methods and techniques are vulnerable to environmental factors like rain and fog, and images required to analyze need to be taken during daylight, as they can't be taken during night time.